All right, there we go. There's the camera I'm looking for. Hello, friends. It's time to do a live stream. So today we're going to draw some images with C#. It's going to be fun. So I'm using the OpenCV library. This is something that I've used before. It's been a long time, so I'm a little rusty, and I haven't really used it with C# very much. I've used it mostly with Python and even Go a little bit. And what it is OpenCV is just something that takes multi-dimensional arrays and turns them into cool images. And so that's what we're going to do today. We're gonna drop some images with C#. So let's jump right in. Jump right into doing that. This is actually, so this is from my previous stream. Let's see. Let's go here and we're going to create a new. What we're going to do is build a console application. So I'm going to build a console app here in C#.NET, and we're going to just run this stuff from a command line, basically. And my camera is going wonky today. So I have to turn it on, refocus it. Keeps going wonky on me. That's one of those things that I'm kind of in the market for a new camera, possibly, or I'll just use like my backup Sony Alpha, but this one likes to go black. So whatever. So let's jump in here. .NET new console. So we're going to call this Image Maker, for lack of a better name for it. Take this open folder. We're going to go to Image Maker. There we go. Yes. All right. So now we have .NET console app here. And I just created this with .NET new, as you can see. Opening up a chat window here so I can make sure and see. So this is just a .NET console application. Go .NET run. You'd say, hello world. Hello world. Great. So I'm gonna go here and we're going to install this EMGU, which is a wrapper for OpenCV for C#. So this is really, really cool because you can, it's just a wrapper that sends OpenCV commands. OpenCV is originally designed for C and C++. However, all these wrappers have come out over the years and interfaces and things like that. You can use it with just about anything. I've used it mostly with Python, like I said, and it's been pretty fun. We're just going to generate images. One of the cool things about OpenCV is generating images is only a small part of what it does. It also reads images, and there's a whole bunch of computer vision stuff you can do with it, which is the whole reason I started learning it in the first place. And I'm still learning the computer vision part of it. But generating images is a small part of it. So I've got some notes here, so I copy and paste so people don't have to sit and watch me type stuff out. Oh, Image Maker. So we're going to do .NET package emgu.cv, the newest version. All right. And we're going to install OpenCV, also the newest version. All right. And then we need to do a runtime for Windows here. And that should be it. So with this, we should be able to generate this hello world here. We have hello world in C#. So let's generate that really quick. And just do another quick tech check. Everything looks good. Up on restream. All right. Just making sure I'm broadcasting here. Still get a little nervous about that stuff. So we're going to take this hello world and it's going to pop this up in a window, and yeah, you'll see. It'll be awesome. We're going to close all this out. stupid camera. You can see it up there being annoying. This is the Alpha 6600. Great looking camera. Absolutely terrible in a lot of ways. My USB connection does not work on it. It overexposes images randomly when I take still images, and it goes black screen pretty much. If you're recording things, like if you're just recording, sitting in front of it, talking, recording even in 4K, it's just fine. But as soon as you stream something, I don't know. Zoom and this, it just does not like. So, .NET Run. There we go. It works. So, let's go through the code first, because that was just a quick check. What we're doing here is we're including emgu.cv, emgu.cv enum. Yeah, no idea why this stupid thing is. Maybe I'm not moving enough for it. I don't know. So, back to, so we're including emgu.cv, emgu.cv.cvenum, and cv.structure. I don't know exactly what these two namespaces do, but you know, I might be able to figure that out later. And what we do here is create a new window. So this is just a string for the title of it, and it says test window. And then we want to do a CV invoke named window. And what this does is it just creates a window that our image is going to live in. And this window is a form element that you saw pop up a minute ago. And it's actually not necessary. We can just generate images and save them on the hard drive. Oh, hey, Sean, what's happening? It says, can you bump up the volume on your mic? I can. How about this? Is this a little bit better? I don't know. I didn't touch the volume since the last time, but things change on this stuff. I've noticed all the time. So this should be a little bit better. I can put the microphone in front of me too. So here we're creating a named window is what it's called. And so this is a window that pops up and shows your image. You can just, like I said, you can just write an image, or you can create a byte stream with it, whatever. But we're just doing this because it's part of the hello world, and we'll have it pop up a window so we can see it. And then here, we're creating a new image object, which is basically like a canvas, I guess you would say. They call it a canvas in Python, and it's basically just a matrix. But we're creating a new one, 200 by 400, depth type, says 3-channel image. I don't actually know what that means, I'll be honest. I think it's an 8-bit depth, but I have no idea what a 3-channel image means. I'm guessing RGB. Those might be the 3 channels, since that's what our colors are, which is our next part. Set it to blue color. So what this does is it creates a new BGR array. And you might be saying, well, isn't it RGB? It definitely is, but it has to be reversed for OpenCV. So instead of RGB images, it just goes blue, green, red. I don't know why. Someone else probably does. And then you convert it to this MCV scalar after that. This is going to set it to that blue color. And this is why I have, if you notice here, I had this RGB BGR color picker here, because we're going to use that to pick colors to play around with stuff. So next is draw hello world, which is cvinvoke.putText. We're going to put text into this image up here. It says hello world. We're going to start it at a new drawing point of 1080. So that's X and Y here. And these are just points in the images. Font face, Hershey complex. OpenCV does not have a great selection of fonts. Most of them look like crap, which I'm sure you can add different fonts, but like this particular library is only showing Hershey stuff, so whatever. 1.0, I believe, is the thickness. I'm not really sure. and then the color, which in this case is blue, looks like. And then we do ImShow, and what that does is that instantiates a window, dumps the image in it so you can see it. Then it goes to cvinvoke.wait key, so it waits for you to press any key. If you press the key, then it destroys it. Destroys the window. If you do anything other than press the key, it looks like it will probably throw an exception. Let's try this again. .NET run. Hello world. As you can see, we have a window, and we'll select it. I'll press any key, and it disappears. And what I'm going to do is probably rob some old Python code. Let's see what happens if you exit it. Yeah, see that? So we'll have to put in some handling for that. So what I want to do is run some commands to grab how much memory I have, maybe grab some CPU info and draw that on here. So we'll just start with this hello world thing that we've got here, but we'll make it a little bit bigger. Let's see what, I don't know, like 800 by 600 looks like. Hello world. It does not look like 800 by 600. That looks like 600 by 800. So I could be mixed up. There we go. Here's a nice big image. Let's change the color. First, let's change the background of this thing. So we'll go here to this color picker. What color should we change it, Sean? What's your favorite color? Green? Blue? Okay, I'll just do green. Green is 255. So 0 with 255 on each side, which actually is the color of our text. So now we're not going to see any text. Voila, there's our green. It's a terrible looking color when it's displayed like that. So let's change this to black. We want our text to be black. And I'm going to go with a different, other than that screaming green color that we just came up with, because that's really unreadable. And I got my colors mixed up. Black's 0, white's 255. Feel free to heckle me in the chat. Okay, so now we got black text on green. Let's make it like a really light gray. That'll be nice and easy to read. Something along those lines, which looks like it's 00204. Or no, it's RGB would be 204 all across the board. So that makes it easy. We don't have to reverse anything. There we go. Hello world. So what I want to do is run some commands that will grab some information about my computer and display it on there. So I have these in my notes somewhere. I have a couple of these. Here's a good one. And this is using WMIC. I can just run it down here. Like get total physical memory. And it says total physical memory, then this. So let's display that on the screen or on our new fancy image. And so you don't have to watch me type it out, I found a little method I call run command. I'll explain it, but I'll still copy and paste it. We're probably going to have to convert this to program main. So one of the things, all the top level statements are eliminated in .NET 6. So when you start a new console application, all the top level statements are gone. It's really convenient and handy if you're doing something small, but this probably looks more familiar, where it creates an actual program class. You have your static void main, all that kind of fun stuff. Since we're putting in another method here, Visual Studio has asked if I want to convert it, and I do. So now it looks a little bit more like a regular console app that you know and love already. Okay, so run command, what this does is it takes a string command. Actually, we don't need parameters for this, because this one I believe will just run the command. If we'll add the parameters back in if we need them. But what this does is it starts process here. It starts CMD process /C, and we redirect our standard output, and then we're just going to grab that standard output and pull it into a variable. So we put redirect standard output to true on this process. Use shell execute false, and that's something that you have to do if you want to grab that stand out. We're going to do create no window because we don't want it to pop up a window, run the command, and disappear. And then we just start the process. And then we have string result, which is process standard output read to end. I guess I could just, I think I can just put this in the result. Save us a line of code. So let's test this really quick. We'll just run like a dir or something. But I wanted to put this into a function because obviously, into a method, I should say. I wanted to put this into a method because we don't want to repeat this over and over for every single command that we're going to have to run. So we're just throwing it into a method. Makes it super easy. We'll do console, write line, run command, dir. Let's see what it does here at the bottom of our console. .NET run, hello world, there's our dir down below. Perfect. So I'm going to take that command that I just ran a minute ago, this memory one. So copy that. This is going to be cool. And let's echo that out. Yeah, we'll clear .NET run. Make sure that it does get echoed out. Now you'll notice that this particular command puts out 2 lines. We only really want that second line, which shows the number. So that's easy enough to do. Let's take this. We'll say string. Stereo SPM. What? String meminfo equals command, and then we're going to say, I don't know what the heck to name this, but we're going to do a string array. Let's say meminfo from CMD, and then this one will actually call meminfo CAD split. We're going to split this by carriage returns. What that will do is give us a string array, and string array 0 will be total physical memory, string array 1 will be this value right here. So instead of hello world, let's just let's drop meminfo 1. Not 2, 1. And let's run it. Voila! There's our info, and then a couple question marks. I don't know why we're getting the question marks. Let's find out. Okay, and we are here. Put a breakpoint there at put text, and memory bin, huh? I don't know what this little binary thing is on the end of here that's making those question marks. But as you can see, we're doing the carriage returns. We're splitting it by carriage return, and then it has this this view binary data. So maybe it's dumping dumping out something that we don't want it to dump. I think I could trim it or something, probably. Trim the blank spaces out of there and see if that helps. And key to close it. Run. There we go. Just trimmed all the blank space and garbage off of it. So there is how much memory we have on our system, which is awesome. Now another thing I'm thinking of abstracting to a function would be this entire put text right here, because like I can copy this for our memory. You can see it's already starting to get repetitive, right? Memory. We want to put this at 10 and 80. I believe 10 is where it starts. Don't know. Let's see here. 10, 100. Destroy window if key is pressed. Oh, I see. I copied the wrong one. So now I have two of these put text methods going on here. Perfect. Looks like it needs to go down just a little bit. So we'll say like 120. Yeehaw. Memory equals then the memory. So I don't want to write this line out every single time. So doing another quick tech check really quick to make sure that this is working as intended. It appears to be. 11 viewers on Twitch. Awesome. Thank you for watching. And we're gonna check LinkedIn really quick. I don't think I'm going on LinkedIn. I think it was, but now I don't think I am. That's okay. We're out there somewhere. Sean found us on LinkedIn, so I must have been on LinkedIn at one point or another. So I'm going to take this here. Now we're just going to assume that we want the same color for all the text. And to indicate that, I'm going to name the method writeBlackText. This one will also be private. Static will say void write black text string text write, and then we need to put in these coordinates. So we'll put in x and y, which I'm assuming, yeah, x and y. So int x, int y. Then we can just specify the coordinates, the text we want to write, and we don't have to repeat this stuff over and over. Ah, but I need to put in this image right here, which is a matrix. That should work. And this will be text to write. And now we have a method here. So we don't have to repeat this code over and over and over and over and over. We can just say write black text. Oops, I did not want that autocomplete. I want a tab. Okay. Write black text. And say memory. Where did we want that? I think that was, where's our hello world? That'll tell us. It started at 10 and 80. So 10, 80. We'll pass in image. Memory, and I put that exclamation mark on there so we know. And there it is. Memory. Cool. So for the next write black text, and we could even you know, if we wanted to get really fancy, we could just create a plain old class object and stuff everything in there. Once we figure out exactly what we want to write into this, we could just do a plain old class object and stuff everything in there, and then pass the plain old class object into a method and have it write out each of these for even less code. So we want meminfo1, and we decided this was going to be at 120. Oh, messed that up. So we did want to trim it. Trim that white space off of it. And I could be messing up my X's and Y's. Oh, I see. I forgot to pass those down. That makes sense. On that run. There we go. Memory. The amount of memory we have. Interesting and fun. So this is how you write text. You know, I think I said in the beginning of the stream that by the time you end up watching this stream, you will know how to create images with C# and OpenCV and EMGU. But it's not just C#. However, we're there. Like, we're making images with this thing. So let's keep going. Another cool command. I'm going to start commenting some of this stuff. I'll put this up on GitHub if anybody really cares. Let's see, get memory info. Next, get CPU info. I will say write to image data, and then show the image. So we'll kind of break this up a little bit. So CPU, string CPU info from CMD, which this one should, oh, look at that. It almost, this almost guessed the command that I have here. Oh, let's see. CPU WMIC CPU get, we'll just say name for now. And then you should be able to go here and say CPU info from command. We'll put this down to 160. And let's see if it gives our CPU info. No, it barely does. It looks like this one, I should have run this command before to see what it looks like before. Oh, and it looks like this one does the same thing. So that's not a big deal. We'll do the exact same thing we did before here. We'll say string CPU info equals CPU info from command. We're going to split this. I don't know why it doesn't like that. Oh. So, creating a string array called CPU info. Then we're splitting that by the carriage returns, new lines, I should say. We're splitting them by new line. So this one will be the same thing as the memory info, where we'll go down to number 1. CPU info 1, and we'll trim it. Now it should look a little better. .NET run. There we go. Now we see Intel Core, blah, 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 blah. Sweet. But there's a ton of of different things that we can get for this. So we can get name. Let's see, CPU get. Let's see how many fields this thing has. Processor ID, processor type, blah, 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 blah. Holy moly. What do we care about here with all of these? We care about, I'm going to put this into a new text file so we can kind of split it up and look at it. Do we care about architecture? Architecture might be kind of cool. Asset tag, availability, caption. No, we don't need PowerShell. Characteristics. There's a whole bunch of stuff. CPU status. I'm a little curious about that one. Let's try that one really quick. CPU status. 1. Bleh. Boring. Creation class name, current clock speed. There we go. Current clock speed. That might be somewhat interesting. Current clock speed, 3504. Let's put that in there. So architecture, I think we care about. Let's see what architecture says. Just says 9. We don't care about that. Let's see. Current voltage. 16. We don't care about that. Data width 64. Bleh. Description might be interesting. A little bit. We'll do it. Let's see what device ID is. Device ID, CPU 0. We don't care about that. We don't care about this stuff. Maybe family might be kind of cool. I don't actually even know what family it is. 179 doesn't mean crap to me. L2 cache size. Yeah, I guess we could do that. So we'll put all of these in here. Load percentage might be kind of cool. Three. I'll do that and jiggle the mouse. 1. Yeah, I don't really care about that one. So far we have architecture, current clock speed, description. All these other ones we're probably not going to. Manufacturer, it should just say Intel. Genuine Intel. Max clock speed. There's a lot of cool stuff you can get with this command. You can get a lot of really cool information. Number of cores, number of enabled cores, number of logical processors. What is other family description? Let's see what that is. Other family description. Okay. So I don't think any of this other stuff, I'm not going to overload this too much. Maybe processor type might be interesting. But basically, this is just going to make a little printout. No, it doesn't matter. Look at all of this stuff. Holy moly. So these ones right here, I think are the ones we care about. And we can stack these. Yeah, paste it. But we have to stack them without the line return. So architecture, current clock speed, description, max clock speed. Let's put that one. Let's put max just in front of current. We'll put in name. Hello, Pratik from YouTube. You're a programming god. Not quite. But I love to do it. I'm an enthusiastic programmer. Description. Oh no, we already did description. What did I do? Okay. Thank you for watching, Pratik. It's always fun to have people join me while I do stuff like this, especially things like this that I don't really plan, that I just kind of open. Some of my most fun streams are ones like this where I just open an ID and I'm like, I'm going to do this. And I do little notes here and there. I try a couple things and then I just turn it on and go and let things break. That's my favorite type of streaming. If I plan it out too much, I think it's a little boring. So this invalid get expression. So I'm just going to stack these on here and say architecture 9. Don't care about architecture. Max clock speed. Start with that one. Current clock speed. Oh, I guess I can't stack them like I thought I could. That's interesting. So, okay, we'll start with name. We already got name here. Where do we have it? Split n, name. And maybe what I should do is abstract this to a function, or method. I keep saying function. And Pratik asked, well, what age did you start programming? I think I was probably like 13 or 14, somewhere around there. I was terrible at it for 10 or 15 years after that. I started doing it professionally in, like my first professional programming job was in 2002. And I actually started out as a network engineer. That's what I wanted to do. That's what I went to school for and got a degree in. And I was going to be a network engineer that like plugs in wires and stuff. And the programming bug caught me fairly early on. I'm just going to call this one, we're going to say, this one's going to be another private static string get info. We're just going to pass in a string array called information. And we're going to, we're just going to take this part of it. Or maybe I could put it in run command, but not every command puts it out. So here's one of the issues here. And this is why I like streaming without a plan, because we can do all this like on the fly refactoring. Not all of them return 2 lines when you ask for something. Like not every time you run this command, it returns 2 lines. So that's why I'm doing it this way. But so far, all the commands we've run have returned 2 lines. So for now, we're just going to do it this way. We're going to say, we're just going to return information split. Split it by the new line. Split 0. I think I can do that. Pretty sure. Why would that not have a definition for string array split. That's interesting. Oh, because I need to just put in the string. Duh. Okay, return information. Sometimes my brain just kind of freezes when I'm streaming. So for now, we'll just say get info. We'll pass that in there. So this one is just going to be a string again. String meminfo. We're going to say get info, meminfo from command. Let's see, CPU info is also just going to be get info, CPU info from command. Perfect. Oh, and we can trim it right here. So now we have meminfo. See, we're reducing code little by little. Little by little, we're reducing code here as we refactor. We'll go to .NET Run, which is somewhere. .NET Run. Terrible. We need the first element as in element 1. There we go. Memory. This much memory. Intel Core processor. So let's change the memory one a little bit here and just say memory equals plus meminfo. So we want that one on the same line. I think that makes a little bit more sense to just say memory equals and then the value. There we go. Memory equals about 68 gigs of RAM, it looks like. And then we have our Intel Core processor. Let's go back over here and see what else we can do. We can say max clock speed. So get CPU info, get memory. Let's say string CPU clock speed equals, how would we do this? Let's see. CPU clock speed command. And we're going to, I'm still thinking of ways we can refactor this a little bit. Command. And with this one, we ran, what was it? Max clock speed. So clock speed from command, string CPU clock speed equals clock speed from command. So now we're just going to run that command, get the clock speed. We're going to write it out. Write, black text. And here we're going to say max clock speed equals CPU clock speed. Oh, we need a bunch of other things, don't we? We need 10, we need 140, and we need image. All right. .NET Run. Max clock speed 3504. This could be at 160. That would be okay. And like I said, if you're just joining my stream now, which I just noticed there's more people coming in, it looks like. If you're just joining the stream now, we are drawing things up in C#, drawing up an image right now that's pulling some of my hardware data from Windows, and we're writing it onto an image screen. I'm going to put all of this stuff on GitHub and on like YouTube and stuff like that. I'll put it in the comments, but I'll be at github.com/Jeremy C. Morgan. I will definitely put this code online so you can kind of jump in and take a look at it. So we got our max clock speed. What was the other one? We were going to do current clock speed. So we have so far, we've written out name, max clock speed. Let's do current clock speed. Actually, I'm going to go through these commands really quick and just see if they're all returning the, let's see, current clock speed. Yeah, if they're all doing this like one line, then a new line and the value, then I think I'm going to combine those two functions. I'm just going to do it and we'll see if it breaks anything. So we're going to reduce this code. This is a lot of code here, in my opinion. So as part of the run command, I would like to just take that second line out of it. So what I'll do is right here where I have return information split, I'm splitting it by new line, selecting the first one and trimming it. That is exactly what I'm going to do with our standard output here. So now we're returning the standard output and we're doing a try catch here. So if it breaks, I'll know it. It'll show it on the screen. But what I'm going to do here is we're returning that standard output. Since each of them seems to be two lines, we're splitting it by new line, selecting one, which is the second line, and trimming it. So we're running the command and just extracting the value that we want one by one, and that should reduce the amount of code we have here. So I'm going to change this to this. And we can get rid of that. CPU info, same thing. This will be CPU info now. Clock speed, same thing. Instead of from command, it's just clock speed. So now we have a little less code here. Now we'll run it and see if it works. And it does. Yeah. All right. So let's just keep filling this up with data, right? And I'm going to call this CPU max clock speed because that's important. And I believe the other one was called current. So we'll, of course, say string CPU current clock speed equals run. Oh, see, the autocomplete figured it out. So I'm running tab 9 on here. And tab 9 is really, really cool. So I have tab 9 Pro, and what it does is it autocompletes. It learns from your code as you're writing code. It learns kind of your style, the way you do things, and then it starts doing some pretty intelligent guessing based on that. And it saw me do this 3 times here. And so now it kind of guessed that I want current clock speed, probably because I put max clock speed here, max clock speed there. Maybe. But anyway, it guessed current clock speed. So we're going to copy this, say current clock speed change this to current. And then we're going to have to move this down to probably 190, I would guess, at this point. And we'll do .NET Run. There we go. Max clock speed, current clock speed. I wonder if I can change this font size a little bit. I'm pretty sure I can. That's probably what the 1.0 is, right? It just says it's a double. Try 0.5. Just kind of want to make the font a little smaller. I think that is definitely font size. Perfect. So I want to make that just a little bit smaller. Maybe not 0.5, maybe 0.7. And this doesn't look like these are spaced very well. So let's go back into the spacing here. We've got 10, 80. Let's add 30 to that. And 110, we'll add 30 to that. And 30 to that. This should space them out a little bit better. There we go. Now we're spaced out. So I don't know if we want to jump directly into clock speed in my little list here, but maybe we'll try description. What is description? Description. Yeah, we can put that in there. So we'll do string CPU description. I'm going to change CPU info to CPU name. Since we're calling get name, we're going to make that name. Then we're going to change this one to description. Then we're going to reorder everything. 140, 170. So I'm scooting all of these down appropriately. .NET Run. Ta-da! Awesome. So we got our clock speed. Apparently I'm running at max clock speed, which cool. All right. Rock and roll. So how long have I been streaming now? Almost an hour. But I'm not ready to shut her down yet, so I'm going to do a quick tech check really quick. Check. All right. Oh, we've got a bunch of people on here. That's awesome. Thank you all for visiting me on my stream. Checking here. Just doing a quick tech check. Oh, I'm live on Twitter also. That's amazing. No viewers, but I'm live, right? That's all that counts. Okay. So we got memory, we've got the name of the CPU, the description, clock speed. What else can we get from this CPU that we care about? Number of cores. Sure. I think number of cores is important. Let's just quick spot check, see what that looks like. Number of cores, 12. Okay. I'm good with that. String CPU number of cores. CPU get. It didn't guess at that time. That's all right. Okay, CPU number of cores. Clock speed. Put cores equals, and then CPU number of cores. And this is going to be at 230. And let's run it. .NET Run. .NET run. Cores equals 12. Cool, we're starting to get some real good info here. And this, I don't know what you would use this for. So a lot of times when I'm building stuff, I try to get a good use case going for it, right? Like, you can use this to do whatever. This, you can use it to generate a JPEG with your CPU info. I don't know how useful that'd be. Maybe bragging rights. Maybe it's kind of like a NeoFetch type thing. You could run this and, hey, check it out, man. Running a i9 processor or whatever. I don't know. Which I really do love this processor. It's a couple years old. There's way faster ones out there right now. But this thing, I really like it. It's fast. Same thing with my video card. I've got an NVIDIA, I don't know. Don't even know what model it is. I could check. I guess I needed to reinstall my NVIDIA stuff. I have a GTX 1650. Again, old, a couple years old, 2 or 3 years old, but it runs games really well. And does rendering, actually. I kick a lot of my rendering off to that when I'm building videos to produce. Renders pretty fast. Everything I do, I don't do a lot of 4K or anything like that, but I have done 4K and it's rendered fast. Most of the 1080 stuff I have just renders in a few seconds, so I'm a huge fan of that. Let's do number of enabled core and see if it's different. I think all my cores are enabled, but they may not be. It's hard to say. Yeah, they're all enabled. There's not really a reason to do that. Number of logical processors. There's a good one to look for. 24. So here we're going to say string CPU number of logical processors. Once again, we're just running this. Now, I could have swore the last time I used this WMIC, I could have swore that you could stack the parameters on it. So I'm not sure why it's not doing that now. I guess I could just Google that really quick. Because that would make this faster. I don't know. Yeah, I don't know. I don't know. I'll have to mess with this command a little bit more. And when I go to refactor this, I will refactor this. I'll refactor it live on stream if people really care about this. So cores, number of logical processors. That's right. Processors, CPU, number of processors, and this is going to be a 260. All right, .NET run. There we go. So I've got some pretty good info here. Let's see what other kind of memory info I can get. What did we do? Get total physical memory. Just do get. Question mark. Help. Invalid query. There we go. Press any key to continue. Holy moly, look at all of these things that we can get. CPU status, install date, cache speed. Yeah, we got all that. We didn't care about that. Designation, voltage caps. Okay, I didn't see a lot of things related to memory here. It's like a whole lot of CPU stuff. Probably not a lot of memory. So this could be where we're at, like the last bit that we care about. So .NET Run. Pretty cool. Maybe we could take this and we'll put it, I'm going to take all of these 10s out where it says 10, that's our margin here. And I'm going to abstract that out into a margin so that we can just move all of these, I was going to say all 4, but it's 7. All 7 of these values will shift all at the same time to where we can kind of shift it where we like it. And actually I'll set a base at the top for the exact same reason. So I'll show you exactly what I'm talking about, what I'm thinking here. I'm going to say int margin equals 10. So in here I can just put in margin, because that's what it is. It's like a left margin. So now that I said that, we're going to call this left margin of 10. So we're going to say left margin instead of 10 for all of these. This is what it's all about, right? DRY, do not repeat yourself. So I repeated this value 7 times. Well, now left margin is 10. So run it. Oh, that's cool. They're all here. I would like to move that to 50. Ta-da, the whole thing moves over. Maybe I want a little bit more. Maybe I want 100. Yeah, looks pretty good. So the top margin is going to be the same thing, except we're going to do plus 30 on all of these. So the very first one that I do is at 110. So we'll say top margin is 110. Or no, the top margin was 80. That's right. Top margin's 80. So we'll just put top margin here. We'll put top margin plus 30 here. Top margin plus 60. Plus 70. Or not 70. 90. Top margin plus 120. Margin plus 100. What? 170. Whoops. And then this one's going to be top margin plus 200. Let's see if that works. I didn't bungle it up too bad. I put too many there. Clock speed. Oh yeah, it went from 120 to 170. So that should be, geez, brain farting today. That should be 150. And then this being 30 more should be 180. So for those following along, you can probably figure out what I'm doing. Basically, I'm setting this top margin as a base, and then all of these things will be so many pixels down from the base. That's what all this is measured in, is pixels. So if I take the top margin to 150, this should shove every single one of them down at once like that, which is great. Maybe 200 pixels might even be better. And so basically what I'm doing is just creating a margin and then using that as a base to bounce everything off of it. So that's a little bit more centered. Let's try this one, 200. Okay, that's a little bit more centered. I like that. I would say even 170, maybe better. Just kind of want to get this centered so it looks okay. All right, relatively centered. I could, of course, take the entire width of the image, cut it in half, blah, blah, blah. I'm not going to do that. But here's our info here. I do kind of think memory should go at the bottom, but that was the first one we called, so it doesn't matter. Let's mess with our text a little bit here. So our text, font face, Hershey complex. Let's look at the different font face options. Script complex, simplex. What's triplex? I don't know. Simplex, duplex, triplex. I don't know what that means. So there's only one way to find out. Oh, it's much bolder. Still a terrible looking font, if I'm honest. I do not like this font. But it's kind of cool. We're dynamically creating this PNG image. Now there is something that I did a while back when I was doing this stuff with Python. I drew a rectangle. Let me jump into that code somewhere around here. Here's what it looks like in Python. So before we do all of this, we should write a rectangle. So I'm going to put in Python, CV2 rectangle, canvas, and then it looks like this is, I believe, color. So I'm just going to try to figure out how to do this on the fly. So we're going to say CV invoke rectangle. What does it need? It needs image. That's our canvas. Left margin, top margin. And it requires a rectangle. Okay. New system drawing rectangle. Sure. Point location and size. So the location is a point 80. Let's just start there. And then we have Y, which we could do top margin, left margin for this, I suppose, but let's see. Top margin, left margin. For now, width of the rectangle. I don't know, 300? Height of the rectangle, 400? And then there's a color. I'm pretty sure I saw that in there. Oh yeah, MVC scalar color, which we've been using those already. We did that right there. So we'll put in new, and we'll choose a color of like white, I would say. So we'll say new, 255, 255, 255. Scalar, and then what else do we need for this rectangle here? Does not contain a constructor that takes 5 arguments, huh? So maybe I'm doing it wrong here. Rectangle. Okay, we've got our image. Got a new rectangle, color, and then thickness. That's all optional, so that should work. What is it complaining about here? Doesn't contain a constructor, so maybe those aren't as optional as I think they are. Common 1. How about a thickness of 1? Actually, let's just draw out our rectangle really quick. System drawing rectangle. We'll call it main box equals CV2 rectangle. Oh, yeah, that's not going to work. So equals new. Put this guy in here. That's because I added that argument. So that's why I do this kind of stuff. Sometimes if you just pull it out and put it in a different spot, it makes a little bit more sense. So I think this will actually work. Do a new rectangle by the top margin. Let's quit talking and draw. Let's see if it does it. All right, so it's a little bit, little wonky donkey. But we're getting there. Now, it's possible that I have these two mixed up. Maybe this should be top margin, and this should be left margin. Perfecto. .NET Run. Nope, that was not it. So somewhere here I am messing this up. Matthias, thanks for visiting. You could simplify your Y values by making a line height constant 30 and a line number counter. Hey, I thought you weren't a programmer. I could have sworn you said at one time you're not a programmer, but you sound like a programmer right now. But yeah, totally. So let's jump in here. And right now I'm trying to figure out my X's and Y's. I'm all over the place. X, Y. So I'm just going to plug these in by hand really quick and see if I can figure out where it's plotting this thing to start. There we go. So you're saying a line height constant 30. And line height times line number. That's awesome. That's a great idea. So as I go through here, instead of top margin plus 30, let's say top margin plus, let's see, line number. I think in C# I can do that. Or it went somewhere weird. But oh, it's because it's not the first one. I'm just gonna dump this in here really quick. There we go. Thanks for the suggestion. I think that's going to work. That makes it simple so I don't have to do the arithmetic in my head, even though it's very simple arithmetic. Thank you, Matthias. Look at that. So now, just to kind of explain what he had suggested and what I did is we set a line number of 0. So this is line 0. And then line height, which is 30 pixels. We determined 30 pixels is pretty decent. And we start with that top margin that's 200 in this case. And so every time we do that top margin, we do 30 times the line number and add that to top margin. And then every time we go, like for instance, just to show, I can duplicate this line and this is already calculated for me. So there it is down there, right where it's supposed to be. So no matter what I put in here, it'll just drop down. And thanks for that suggestion. That was very smart. Okay, so where was I before? Oh yeah, we're trying to draw a box. That's right. So system rectangle. Where is our rectangle? And I think the rectangle is supposed to be filled. And this is where I'm going from. I'm used to dealing with it in Python, and I put my Python code here. Yeah, up here somewhere, and there's a color, and it's filled, and everything's great. I don't know how, without looking at the documentation, which I will do. I will do that. I'm just kind of poking around for now, trying to figure it out on my own. And it looks like 300 is not enough. So I'll hydrate my brain a little bit more with some ice water. 300 width is not enough. Looks like it's probably more around 7. Oh, and there is something that I did do with images in Python that I want to do here. It's fun. I'll try to do that after we figure this thing out here. $600 looks okay. Actually, I'll take that margin, our left margin, put it over here. .NET Run. There we go. Just kind of pulling the text in there a little bit more. And for the top margin, and so there's a lot of this like changing, hit enter, change, hit enter. Kind of the name of the game. Yeah, we're getting pretty close. 280. Yeah, pretty close. I'm going to try not to be too much of a perfectionist on this. Okay, perfect. So now I'd like to figure out how to, and I'll go ahead and just drop this in here. I mean, this isn't too bad of a, actually we'll keep them separate so it's a little bit easier to look at. We'll put create our rectangle. Just try to be a little bit more clear here and say draw our rectangle. So one's creating, one's drawing. Now I do remember some things here. We have line type. Let's look at this here. So we have our array that is passed in by reference. We have rectangle, scalar, color. So we're doing a color of black, or I mean of white. And then thickness equals 1, which I'm assuming is the thickness of the line. Line type 8 connected, that sounds good. Int shift equals 0. I don't know what shift equals 0 means, so I'm going to change shift equals to 1 and see what that is. How many parameters do I have to skip there? Just 1. Okay. Oh, it's not nullable, is it? No, it's not. So let's figure out the line type thing, what it means. Line type 8 connected. Oh, maybe line type filled is what I'm looking for. Let's try that. Filled sounds reasonable. Something died here. Unhandled exception. Connectivity, H connectivity 4. Type 8 connected, which I believe was the default that it was showing us. Yeah, that's line type 8 connected. And then I'm going to change that shift to 1 just because I want to see what it does without reading what it does. That shifts it in a weird way. Don't need that. So let's try the different line types and see. Line type anti-alias seems interesting. I don't know that that's anti-aliased at all, but sure. We have line type 8 connected, line filled, which broke it. Let's see why. Unhandled exception, line 39, which is, yeah, that makes sense. Line type filled. Let's try 4 connected. Four connected looks just like 8 connected. So I'm going to Google it. Let's say CV. I guess I could just Google it here. emgu.cv. I'll say here. And our method is rectangle. Filled. This should take us right to where we want to be. So here we're looking at the syntax that we were just looking at before. And there's our output array, rectangle, the color, thickness, line type, shift. Number of fractional bits in the point coordinates. So that makes sense why it went zappy as soon as I messed with that shift. That actually makes sense now. Thickness of lines that make up the rectangle. Negative values make the function draw a filled rectangle. All right. That is exactly what I was looking for. So, should be able to just change that to a -1 and get our filled rectangle. Ta-da! I used to have sounds on here. I need to put my sounds back. I had the ta-da sound when something went cool on my Stream Deck, and then I had that wah 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 when something broke. So I need to bring that back. It's a good note to self, because it's kind of funny. So what I did in on previous projects is I made a gradient for the background, and the way I did that was with a loop that would go and change the color in the like dynamically as I loop through. So I'm going to try to do that again. We can get rid of this. We've checked off a lot of boxes here, right? So I'm pulling all of this CPU data that I want to pull. I've got it formatted pretty nicely. I've got a nice little rectangle around it. Now I want to make this a little more interesting here in the background. So of course I can go up here, wherever we're at, and right here, set it to blue color, which was from the hello world. We're not setting it to blue anymore. Gray. Let's color picker. We'll choose something like a red. That's 25500, which means this should be 0, 0, 255. BGR. Oh, neat, it's red. But we can scale this down And the way I did it was doing lines. So I draw lines across that background. I'm just going to put here, draw a fancy background. Background. And by fancy, I mean something that looks like it was put on a web page 20 years ago, right? When the god-awful gradient era of web design. But that's part of why I do it, because I just wanted to do it. So in here, line, I believe, let's see what line is here. CV invoke dot, there we go, line. There's our input array, which we already know is image. And then we have 0.1, 0.2. So new system drawing point. 0, 0 is fine for now. We'll do a new point. We'll just draw a diagonal one here, diagonal line. So we have 0.1, 0.2, the color again, and the thickness. So for our color, we will do, what should we do for a color? Probably white will show up the best. So these are other things that I can abstract out to variables for sure. Let's see. But for now, we'll hard code them in there. So now we have our color, line thickness of 1, and then we have the line type and shift again. They're pretty optional. So bring it over here where people can see it, and we'll run this. We should have a little white diagonal line. There we go, white diagonal line. So what I do here is 0. Now it should not be diagonal at this point. However, I got my X's and Y's mixed up. So we know the width of the image. Let's pull that out to a field also. Show. We have 600 rows, 800 columns. So int width 800. And this is once again so we can just go back and change this stuff willy-nilly and not have to go updating everything. So this should draw a white line across the width of the image. Be really hard to see because you can't. So let's do black. Maybe that one will show up a little bit better. Yeah, that one shows up a little bit better. So we have that. The next one, and I think we should probably, yeah, I think I could make a method out of this. Might make it a little bit easier. We could make a method with, let me think about this for a minute. So yeah, a method with integers that come in. That's a lot of integers there. It may not save me much to do that now that I think about it. So what I'm going to do is we'll put in a for loop for int less than the height, which we have not established yet. So this is going to, let's go ahead and put it in so we don't get the squiggly line. Height 600, correct. So what we want to do is just iterate through every single row in this. So we'll go here, height, width, and to test it really quick, change that to I. Now this should fill the entire screen with white lines. No, it does not. Or black lines. But I'm close, very close. So probably this one needs to be changed to I. Oh, I don't know what I did there. It's Friday, need more ice water. Okay, there we go. So what I've done here is just a step back through it, is doing a for loop, and we're iterating through 600 times for the height. And for each of those 600 times, we're using I to increment. So this is one of the things that I've talked about in my articles and my streams before, that I like for loops better than for each loops. If you used either of those in C#, you know that for each is like really easy. Like for each line in array of lines, super easy. Then you can take that line and say line dot whatever, or line bracket whatever. But I really like using for loops only because I use this index. For loops, it gives you that built-in index that you can do stuff like this. Like I want to know exactly which line I'm on. Well, that's I, and it's right here. So what we're doing is saying, you know, for each line in height, 0 through 600, we'll loop through, and we'll start it here, and we'll end it here, and we're using I to go doot, 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 all the way down the screen. So we know that we had a red background, but it's turning black because we just drew a whole set of black lines over it. And the reason I'm doing that is because we're also going to use that I to change the color. Let's just put it in here, for instance. Check it out. Isn't that awesome? So what it's doing, and there's only 255 different variables here. So that's where we've run into the problem, like through 255 through 0, it does this, and then after that, it's just blue. Well, we're putting in a little gradient here, and depending on where we put this I, it's going to change the color with every single line. So we'll do it here. Whoops, I don't know why I put 1 when I wanted to put I. Ah, we got a green. And now we have red. We will have red. Red. Ta-da! That'd be another think time for the ta-da wave. So this basically starts black, and then it adds a bit to that BGR array. Every single loop adds another bit and another bit and another bit and another bit, which is cool. Maybe I could do divided by 2 or something. I don't know. I haven't tried this. Which might be a problem with 0, right? Oh, so you divide it by 2, and I spread that gradient out a little bit. So how about by 3? Run. Oh. By 3, look how smooth that is. So now we have this nice smooth gradient where it goes from black and it slowly transitions into red. And of course, if we move it, we can make it blue and green. If you haven't guessed yet, blue is my favorite color. So I'm just going to switch this over here. And look at that. It looks like a GeoCities site, but it's cool. So this is our system info. Let's put a system info tag in there. And then I'm not sure what else to do with this thing today. We can always add on to it. And like I said, I'm going to put it on GitHub. So write black text. Let's make one of these called write header. We'll make a big header here. This one's going to be font face of 1.1. It's going to be white. And we'll figure out where it's going to go. It's also going to be Hershey triplex. And we'll start. This is where we start running commands. This is where we set all our margins. I think this is a good place. This is where we start writing, is actually down here is where we start writing. So I'll put start writing our image. And here, whoops, we're going to put right header, Jeremy's system. Where am I going to put that? Oh, I don't know. 100, 200, or 300 for now. Oh, got to pass in the image, which is at the end. Don't know how to use my own method. You could stretch it to the full size with I times 255 divided by height. Another great suggestion. Let's try that before I write a header. Go back up to here. And this one. Now that I know you're a programmer, Matthias, I'm going to bring you into more stuff. You know that, right? Hope you know that. Height. Let's see what that looks like. .NET Run. Yeah, that looks good. And now if we change the height, so this is how we spot check this, right? Let's make this height huge. And this is how we spot check all of our dynamic programming that we're doing. And look at that. We have changed the height of the image and it's stretched it out and smoothed it out. Awesome. That's perfect. And if we make the height smaller, like unusably small, there we go. And it's adjusted the gradient accordingly, even though half of the image is gone. Oh, yeah, it should be camel case, I think, right? Right header, right black. Oh, mostly camel case. These are all private, so they should be, yeah, I think they're all camel case. So yeah, that is smooth. Yeah, I like that. That divides it by the height and kind of makes it completely equal. So, and this only works from like black to whatever color you're going to. I don't know how you would do like a blue and a black, but I'm sure it's, or I mean a blue and a green or something like that, but I'm sure it's possible. I was going to draw a header. The header is not there. So right header, Jeremy's system, 100, 300. Yeah, I usually do camel case and methods, and if it's a public method, then I'll capitalize the first letter, and if it's a private method, like all these, then I lowercase camel case for these. I think everybody has kind of a different style and way of doing it. And part of my problem is that it looks like main is capitalized, so maybe I should capitalize all of them. Part of my problem is that I write in so many different languages that I will take my syntax and my habits from different languages, and sometimes it's goofy. A lot of people have called me out for doing what I did right here, which is, this is not C# friendly. In C#, there we go, at least that one was. But in C#, we don't do that. In JavaScript, we do. So that's one of the issues I have, is I have a lot of habits that I carry from other languages. And yeah, some C# folks have definitely called me out for this one right here. So since we're in C#, I'll put it in there. And I want to draw this header. So where did I put that? There it is. Right header, Jeremy system. And in right header, we have text to write, blah, 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 blah. Black, maybe that's why it's not showing up. Is it black? No, it's white. Yeah, so this should show up. Why is it not showing up? CV invoke put text. XY. Maybe it can't be 1.1. Should be able to though. I don't know why it's not showing up. So let's figure it out. Right header, Jeremy system, CV invoke rectangle. Yep, image right there. Should be. Where are we starting? We're starting this at 130. So that should be a good place to start. 130. We'll try 50 pixels down. Sean says, I learned a camel case private and uppercase all other method names. Yeah, that's generally how I try to do it. And it's kind of like fields. Some of these fields, field naming, I do wacky things sometimes when I forget that I'm in C# also. There we go. There's Jeremy's system. So 50 down, let's say 200 over. That's a little closer, 300. We could just divide this by the width. I could just guess what the width is of this thing. Which I could if I write the style, or if I write this image and then go and get the coordinates. I'm going to guess this is 200 pixels wide. So we're going to say width minus 200. Divided by 2. Oops. Let's see where this puts us. Way off. I was thinking times 2. I don't know what I was thinking. Width minus 400. Let's start there. That should be right in the center. Width minus 600. That's pretty close. It's getting there. I was going to try to make that scalable, but I think if our width is 800, middle point's going to be 400. I mean, 350 should put me right where I want to be, right? Or if maybe I'm just totally confused. Probably am. See, Matthias says text writing APIs can usually be called in a measure mode to tell you the text size. That way you can follow up with a second call that puts it in the right position. Might not be. That's probably a good point. I could do a character count and then multiply that to find that width. Could multiply it by 15 pixels or something. Let's see. String header message is Jeremy system. We could do, let's see. Only a fixed width font. Good point. This is probably not a fixed width font either. Header message length times 15. Let's just see. This should be off to the left. No, that's pretty good. 17. Yeah, that kind of centers it somewhat, but I don't think it's a fixed width font. Doesn't look like it. I'm not much of a font expert. You don't have to be a font expert to know that this one is terrible. I don't like it. It's okay for what we're doing here. We're generating images. And so far through this entire stream here, we're just about getting ready to wrap up, but so far through this entire stream, I've been popping this up in a text window, but you can actually write this also. So how about we show it, and after the key press, we'll save it. Write. I'm trying to remember what that method is. I don't think I have it in my notes anywhere. I think it's like, I am right. There we go. I am right. File name, image, our image.jpg. Input array, that's going to be image. And then, yeah, I think these are all optional. Right flags, parameters, yeah. Maybe they're not optional. Oh. MG. All right, let's try this one real quick. .NET run. Ta-da! Press any key. And there's our image. It's written. It's written and ready to go there. So one of the things you can do with the GIMP, which I don't know, maybe you can do it with Photoshop. Not really sure, but in GIMP you can get coordinates. Let's try, I got Photoshop open. Let's go to our repos. What do I call this? Image maker. I should know the answer to this, but I should be able to pick coordinates from here. I don't know. Maybe not. I would be shocked if you couldn't pick the coordinates from Photoshop, but in GIMP you can just hover over and it gives you the coordinates. So you can say, well, I think I want it roughly here to here. Whoops. I'm like dumping lorem ipsum all over the place here. But yeah, I'd be shocked if you can't get coordinates from Photoshop. I just don't know how right now. Let's see, view. Guides. I don't know. But getting ready to wrap it up anyway. But yeah, here's the image. It's JPEG. And I don't remember, but I think you can use these parameters to save it as something else. Saves the image to a specified file. Image format is chosen by the file name extension. Saved. Format, depth of color is different. So yeah, maybe we'll try saving this as a GIF, whatever. Don't drag me. And that, oh, because so if I gotta wait for the key press event. That's right, so I have to press a key instead of using the close thing. And it's still dying, so I don't think it likes to write GIFs. Let's see here. Spread it up here. Clear. All right, could not find a writer for the specified extension. So let's try PNG. Press any key. And there's our PNG. Cool. So again, usually when I'm doing streams, I try to get something really useful out of this, but I can't find a really great use case for being able to write an image like this. It's cool. Like there's no doubt that it's cool to do, but I don't know of a really good like professional business use case for this other than art. Now, I have seen some things on TikTok where folks are like building things in using Python and using mathematics to draw all these like cool shapes and interesting stuff. You could definitely do that with this. Or like I said, you could make a badge. Like if you could make this look really nice and cool, you could make a badge for people to run on their machines, or you could do it over the web. That might be something kind of cool too, is you build a web app, because OpenCV should work like on an ASP.NET thing, or like an Azure function, or AWS Lambda. Maybe write something over the web where like somebody shows up and it draws something customized for them. Like here's your IP, like the stream that I did the other day where I said, here's your IP. Maybe you could do like an IP thing and a drawing of a map, and I don't know. There's probably some really good use case for this. I don't know, but it's just fun. And that's why I did it today, because I thought it was fun and I wanted to share with everybody else how easy this is to do this. And so if it spawns any ideas with anybody else, feel free to let me know. And so today we generated this on this stream. We basically ran some commands in Windows to grab some information and draw it up on a rectangle with a cool gradient. And it's fun. You know, it's not really super useful, but it is super fun. So if folks who are watching, thank you all, by the way, for watching. For folks that are watching, if this is interesting stuff, I'll keep doing more of it. I've tried to get into the computer vision side of things. I just haven't had a lot of time to really read it and study it. But OpenCV not only generates images, but it reads images, and you can do like, is this a hot dog type thing with that. It does like edge detection. It does all kinds of neat stuff. So if you tie it into some kind of database, you can train ML models off of it, things like that. Definitely something by the end of the year that I really want to get into with this is more the computer vision aspect of it. So that's something that I'll probably do on stream. You know, as I learn, I will share what I've learned on here, which is kind of what I like to do. But I'm going to wrap this up. This has been really fun. Thank you, everybody who has jumped in to the chat and everybody who's watching. Super fun. Love doing this. This is just something I decided to do on my lunch break for fun. Jump on here, and it ended up being 2 hours. That's okay. I'll probably do this every Friday on my personal channel. I'm also streaming for Pluralsight under Pluralsight_live. So if you're following me on Twitch, follow me on Pluralsight Live on Twitch. So it's twitch.tv/Pluralsight Live, and I'm going to be doing streams every Tuesday for Pluralsight. And David Neal, who's one of my teammates, does streams every Thursday. And David is very interesting and engaging. I think his streams are better than mine, but don't tell him I said that. So definitely follow Pluralsight_live. And every Tuesday I'll be streaming something. Every Thursday David's going to be streaming something. I'm going to get Matthias here, who's in the chat, to stream some stuff. And we're going to just keep putting cool content on there. So it's twitch.tv/Pluralsight_live. And yeah, go ahead and check it out. And I will see you all next Tuesday if you're following that. And we're going to do something cool with .NET on Tuesday. I haven't decided yet. And it might be similar to this style where I just jump on and open an IDE and see where it goes. It's kind of fun. Anyway, thank you everybody for joining. I'll be putting this up on my GitHub, even though it's not much. I will put this on GitHub along with some instructions and maybe write an article about it. I don't know if it's interesting enough. But anyway, thanks everybody.